Solar activity fluctuates in a rhythm of about 11 years, which is reflected among other things in the frequency of sunspots. A complete magnetic period lasts 22 years. Scientists have long been puzzling over what causes this cycle. It must be related to the conditions beneath the skin of our star. A layer of hot plasma, electrically conductive gas, extends from the surface to 200,000 kilometers below. The plasma within this convection zone is constantly in motion. A team of scientists from the Max Planck Institute for Solar System Research, the University of Göttingen and New York University Abu Dhabi has now succeeded in drawing the most comprehensive picture of the plasma flows in north-south direction to date. The researchers have found a remarkably simple flow geometry. The plasma describes a single turnover in each solar hemisphere, which lasts for about 22 years. In addition, the flow in the direction of the equator at the bottom of the convection zone causes spots to form closer and closer to the equator during the solar cycle. The number of sunspots on the visible solar surface varies. Sometimes there are more, sometimes fewer. The distance between two sunspot maxima is about 11 years. After 22 years the sunspots are again magnetically polarized in the same way. During the maximum not only large sunspots appear, but also active regions. In addition, impressive arcs of hot plasma reach far into the solar atmosphere. Particles and radiation are hurled into space in violent eruptions. At the activity minimum, however, the sun calms down noticeably. Over the course of a solar cycle, the meridional flow acts as a conveyor belt that drags the magnetic field along and sets the period of the solar cycle, says Professor Dr. Laurent Gizon, MPS Director and first author of the new study. Seeing the geometry and the amplitude of motions in the solar interior is essential to understanding the sun's magnetic field, he adds. To this end, Gizon and his team used helioseismology to map the plasma flow below the sun's surface. Helioseismology is to solar physics what seismology is to geophysics. Helioseismologists use sound waves to probe the sun's interior, in much the same way geophysicists use earthquakes to probe the interior of the Earth. Solar sound waves have periods near 5 minutes and are continuously excited by near-surface convection. The motions associated with solar sound waves can be measured at the sun's surface by telescopes on spacecrafts or on the ground. In this study, Gizon and his team used observations of sound waves at the surface that propagate in the north-south direction through the solar interior. These waves are perturbed by the meridional flow. They travel faster along the flow than against the flow. These very small travel time perturbations, less than 1 second, were measured very carefully and were interpreted to infer the meridional flow using mathematical modeling and computers. Because it is small, the meridional flow is extremely difficult to see in the solar interior. The meridional flow is much slower than other components of motion, such as the sun's differential rotation, Gizon explains. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new science inventions in future.